Thank, th- Thank you very much, Doug. Good afternoon, everyone. We have a two-part program this afternoon. The first half hour, it is my pleasure to introduce Professor J.J. Schenker from the University of Wyoming. The second part of the program will involve discussions of the issues, problems, and conditions in the Rio Grande and in the Republican basins. And we'll have a little discussion about that as we go along. I'd like to, at this time, to introduce Associate Professor of Geography at the University of Wyoming, who specializes in the areas of climatology, paleoclimatology, hydroclimatology, environmental change, water resources, drought, and related topics. She is well regarded throughout the West for these specialties. And so would you please join me in welcoming Professor J.J. Schenker. Professor, it's all yours.
Thank you very much. I appreciate that. Good afternoon. Thank you for having me here. We queued up? Great. First, before I get started, I have to thank you for inviting me here, and I also have to thank the people that I work with, my graduate students, the undergraduate students, and my peers who have worked with me, as well as the folks who have funded a lot of the research that's going on at the University of Wyoming in our climate lab. As a little outline, I want to give you a sense of timescales, rates of change as it relates to things like precipitation, the position of the jet stream, how that impacts and controls the delivery of precipitation, and a variety of different climate processes. So we're going to start as far back as 20,000 years ago in terms of thinking about the presence of a really large ice sheet in the northern part of North America, and what that meant in terms of the shifting of the jet stream, what that meant for the delivery of precipitation for those of us here in the interior Intermountain West. Then I'm going to move on and provide some evidence for past droughts. We look at the evidence and we identify past droughts using a variety of different proxy data. In particular, I'm going to be focusing on today variations in lake level that we measure through ground penetrating radar, variations in vegetation, and also changes in fire as it results from evidence from charcoal, from sedimentary charcoal, from sediment cores from lakes. I'll also provide some examples of present drought as it relates to modern droughts that have occurred over the last roughly 100 years here in the region. I'm going to use those modern droughts as examples for looking at how the atmosphere moves, how it operates, how it delivers or doesn't deliver precipitation or moisture into our region. And then I'm going to pivot and talk about some rates of change that are outside of the long-term perspective of ice sheets, but closer to what we're facing in the future in terms of increased temperature and what that means for water resources. So let's start first in outer space. When I'm talking about changes in the presence or absence of ice sheets, this actually relates to the jet stream. This is a long-term variation of our climate that is forced outside of the climate system by changes of the Earth's orbit, the shape of the Earth's orbit, the tilt on its axis, its wobble like a top. Those are components of Earth's orbital variability that vary on very long time scales, on the order of tens of thousands to even hundreds of thousands of years. An example here is this animation showing the shift of the Laurentide ice sheet that existed in the northern part of North America about 20,000 years ago. What's interesting about the presence of this ice sheet is this is a big chunk of ice, about 2.5 kilometers thick, spanning from basically roughly the Pacific Northwest over to the East Coast, about as far south as Chicago. Now imagine a big chunk of ice about 2.5 kilometers thick and what that does to the jet stream. It's sort of like a rock in a stream. The jet stream gets shifted. Today, the top image is a reconstruction using a global circulation model, so the outline of North America looks a little rough here. But it gives you a general sense of what's happening with the jet stream on a day-to-day basis. This is oftentimes what we think about when we deal with weather changes from a meteorological perspective on a day-to-day basis, those shifts in the jet stream. In the top, the jet stream on average is shifted towards the north, except for those poor folks in the Great Lakes region. They're really experiencing that southern shift of the jet stream right now. But about 20,000 years ago, when there was a presence of a big ice sheet, that jet stream was shifted farther to the south. It deprived the Pacific Northwest of their now normal modern precipitation that they typically receive, and it made the Southwest considerably wetter than it is today. That shift in the jet stream was actually pretty important in terms of identifying what's happening here in the interior Intermountain West. Now, here in the interior Intermountain West, 20,000 years ago when the jet stream was shifted to the south, we're sort of located at the northern extent of the southerly shift. Presently, we're sort of positioned at the southerly extent of the northerly shift of the jet stream. In other words, even on thousands of years of time scale, this region in the interior Intermountain West still experienced a great deal of variability as it relates to the shifting of the jet stream. That shifting of the jet stream and the variability that we see in terms of precipitation is illustrated on the left-hand side of this slide. Here we're looking at the dominance of the dominance of winter precipitation on the west coast, the dominance of summer precipitation to the east of us over in the Great Plains, and then there's the region of the interior Intermountain West, which doesn't really have dominance of winter or summer precipitation with the exception of our high elevation snowpack that we get. This illustrates the sort of vulnerability that we're facing here in the interior Intermountain West as it relates to variability, which is, in a way, our baseline, if we think about it, especially as it relates to our headwaters in the interior Intermountain West. Now, one of the ways that we have looked at changes in the past is by going to a variety of different high elevation lakes, identifying changes in water level, and also identifying changes in vegetation and fire. We do that by taking sediment cores from the lakes. On the lower left side of this image is myself and one of my colleagues, Brian Schumann. We're taking a sediment core from a lake, and you can see those sediment cores in the center. They provide us information about pollen and charcoal over thousands of years that help us understand changes in the environment, variability that occurs within the region. On the lower right is an image of Brian and one of his colleagues pulling his $60,000 geophysical technique tool in a $20 Walmart inner tube. What's really amazing about these pieces of evidence, about these proxy data, is they help provide us context. They help to include a longer range of variability. It has been dry in the past. We have historical records to show that. It has been even drier in the even longer past by this evidence that we have been collecting from these lakes. An example is some of the ground penetrating radar data that's being shown here. This is actually from Emerald Lake, which is part of the headwaters of the Arkansas River. In terms of the Arkansas River, on the bottom image, you can see this big arrow pointing to this tan line. Those tan lines represent sand lenses. They're evidence of past shorelines. They're evidence that the lake in the past was considerably lower than it is at present. It gives us an indication. It also gives us something to measure in terms of volume of water that provides us context for past droughts. In particular, this one that I have pointed out here on the bottom, this drought was about 1,100 years ago, and it lasted a number of years, on the order of decades to probably hundreds of years, or what we would often refer to as a mega drought. What we do is we take that information from the ground penetrating radar in terms of lake levels, and I go to the modern record and I find periods in the modern record where it has been dry. Perhaps not as dry as it was in the past, but they're good analogs. They're examples that I can take and utilize in terms of looking at actual atmospheric moisture, the movement of the atmosphere, and how some of the climatic processes occurred to provide us some context for how those droughts occurred in the past. In other words, the proxy data identifies a state of change. There was a drought. There were low lake levels. The question is, how do those come about? And if we understand how those episodes, how those extremes come about, that helps us understand some of the processes in the atmosphere so we can prepare for the future. So here we're looking at a series of maps. These are what are referred to as modern climate analogs. I've taken these episodes in the modern period of these very, very dry conditions, averaged them together, and compared them to a long-term mean. The data that I'm using is coming from the NCEP North American Regional Reanalysis data set. What's really interesting about this particular data set is it doesn't just provide temperature and precipitation, because while those are important, they don't tell the whole story of drought. Because the story about precipitation is as much about water availability as it is about the mechanisms that create precipitation or the mechanisms that suppress precipitation. Another reason this data set is really useful to use from my perspective is that it comes at about a 32-kilometer grid scale. That 32-kilometer grid scale allows us to look quite closely at individual watersheds. So we can actually get to some of the differences in between watersheds. Maybe it's dry in one watershed and it's not dry in another. And we can actually start to tease apart some of those differences and some of the climatic controls that lead to those conditions. In the upper left, we've got precipitation rate. Hey, look, it looks dry. In all of these maps, the center value or the zero value represents normal conditions. If it's sort of on the orange-red side, it's pretty dry. If it's on the blue side, it's wetter than normal. On the upper right-hand side is temperature. Now, of course, it makes sense. Hey, if it's drier than normal, temperatures are going to be higher than normal too. There's a good positive feedback loop that occurs with that. But what's really interesting is to look at the delivery of moisture, the availability of moisture, and how that moisture either moves into a region or doesn't move into a region. On the lower left-hand side, you can see this sort of region of drier than normal atmosphere. This is the moisture that's available in the atmosphere for being lifted up and for precipitation to actually occur. On the lower right-hand side, we've got an indication of the shape of the atmosphere. In this case, the orange-red colors give us an indication that there's a persistence of high pressure that occurs, really centered kind of on the interior Intermountain West and into the Great Plains. That high pressure has this clockwise circulation to it. That clockwise circulation is essentially delivering or helping to continue to deliver increasingly dry air that is present that we can see on the lower left-hand corner of these maps. These are good analogs for the drought that occurred in the headwaters of the Arkansas River about 1,000 years ago, about 1,100 years ago. Another basin that we're connected with between Wyoming and Colorado happens to be the Green, as a result of it being the headwaters of the Colorado, or the largest component of the headwaters of the Colorado. Here we've got an image that shows Lake of the Woods, above any impoundments on the Green River, headwaters to the Green River, right on the Continental Divide. The black dashed line in the image of the top gives you a sense of where the actual shoreline was in the past as a result of the data that we've collected from these ground penetrating radar measurements. What's interesting about this is we can actually measure the volume of the lake today as compared to what the estimation of the volume of the lake was in the past. We can take that data and actually we can identify the distribution of that water within the basin, how much that represents changes in precipitation minus evaporation, and the duration for which that drought occurred. In other words, thousands of years in this case. So when Brian earlier said, hey, we've had droughts and they've been even worse in the past, he's right. There have been droughts that have been on the order of hundreds to even thousands of years that are actually part of the natural variability that occurs in the interior Intermountain West. we can actually take these numbers in terms of the changes in precipitation minus evaporation and compare them to, again, modern data. On the top image, we're actually looking at precipitation minus evaporation, and we've selected years that have those same incredibly low values. So in a way here, we're comparing a type of apple with a type of apple. Low water values or low effective moisture in the past compared to low effective moisture today in the present. You can see on the bottom the standardized precipitation indices for each of those years with the arrows give an indication of, yeah, it was dry back then. So we have a case of extreme conditions. We have evidence for similar extreme conditions, but perhaps not as closely grouped together as they may have been in the past. But here's what's really interesting to me in terms of thinking about how the atmosphere operates, how it moves, how it works. When summarizing climate variables related to extreme events by way of looking at modern events as analogs for past droughts, we're able to identify lower than normal precipitation. We're also able to identify lower than normal specific humidity. But what I want you to focus on is in the lower left corner. This variable is referred to as vertical velocity. It's a measurement of how fast the atmosphere rises or the atmosphere sinks. Anytime the atmosphere rises, if there's moisture available, you'll likely get precipitation. But if the atmosphere is sinking, you're likely to see suppression of precipitation. So note, on the upper right-hand corner, we've got some regions to the southwest that have higher than normal atmospheric moisture. But over the headwaters of the Green River, in the lower left corner, there's a dominance of sinking motion. So in other words, there may be moisture in the atmosphere, but if there's not a lifting mechanism to lift that moisture, you're not going to get precipitation. So this notion of motion and atmospheric moisture and availability, we can't really get at through those proxy data. We actually need to understand modern climate processes in order to identify what some of the controls are in terms of those past droughts. Getting a little bit closer to the Wyoming-Colorado border in terms of thinking about the North Platte headwaters. I did some work with a recent PhD graduate from University of Utah who cored a lake in the headwaters of the North Platte Basin. She was actually looking at pollen because she was interested in vegetation changes. Note the area that's sort of shaded here in yellow. Now the way we look at and the way we talk about diagrams like this is we look at the y-axis as time. So the top of the y-axis is present, the bottom of the y-axis is 13,000 years ago. Each of the columns with all those crazy wiggly lines represent different vegetation types based on their pollen that tireless graduate students and undergraduates sift through and look at in microscopes. That vegetation, those pollen grains tell us something about what type of vegetation is growing in that region at a point in time. That shaded in area that you see about 4,200 years ago, there was a big shift in vegetation. Not only was there a big shift in vegetation from pine to what we refer to as populus or aspen, but there's also evidence of a lot of charcoal in these sedimentary cores around that same time. So there's a combination of drought, changes in vegetation, and evidence of fire that are occurring simultaneously about 4.2 thousand years ago, which also happens to be a time when there was a very large mega drought present in part of the western US and also part of the Great Plains. We're able to connect that data with information about sand dunes and how the winds are flowing based on the sand dune reconstructions, and we can actually identify, sure enough, using the modern record, abnormally low amounts of atmospheric moisture during times that show similar conditions, similarly dry conditions. So the notion here is that we have persistent conditions that are occurring over hundreds of years, perhaps punctuated by individual years of wetness, again, because there's a high degree of variability. But the notion here is that the persistence is occurring, leading to extreme vegetation changes, extreme fires, and changes in water availability. So those are sort of thinking about some of the processes. What I want to do now is I want to pivot to the notion of what we are facing now presently and where we're headed towards in terms of the future as it relates to water resources. Staying in the North Platte headwaters, here we're looking at a variety of different components as it relates to water resources. Now, I mentioned earlier that temperature doesn't really necessarily control precipitation. What controls precipitation is moisture availability and some sort of uplift mechanism. However, temperature does play an important role from a water resource perspective. And here we're looking at temperatures from the early 1900s to roughly present in the North Platte River Basin. We see an increase, a statistically significant increase in temperatures within that region. That increase is occurring annually. That increase is occurring, in fact, every season. Here I've plotted the annual increase in temperature in gray and the increase in temperature during March, April, and May. Those are the springtime temperatures. Those springtime temperatures are the ones that are really important from a water resource perspective. That gives us an indication of when our snowmelt is likely to run off. What we found is that the springtime temperatures have increased in the North Platte Basin considerably faster than they're increasing overall from an annual perspective. Maybe put another way is springtime temperatures are increasing about 1.5 times the rate as the increase that's occurring annually. Put another way, we've seen since the early 1900s about 2.21% or 2.21 degrees C increase since the early 1900s. That's a lot of warming in a short period of time. That warming over that short period of time is actually important when we're thinking about our winter precipitation. Here we're looking at winter precipitation annually in gray, but here I've put winter, December, January, February, in black. While our annual precipitation is highly variable, which you can see year to year has a high degree of variability. The overall decline is evident, but not statistically significant from an annual precipitation perspective. But from a wintertime precipitation perspective, that is statistically significant. We have seen a statistically significant decline in snowpack. So that notion of elevational changes in snowpack and the elevational changes on the behavior of snowpack is actually pretty important for us to consider currently and also moving forward from a water resource perspective. So we're taking temperature and we're looking at snowpack, and then we're relating it to stream flow and the timing and the changes of stream flow discharge. In terms of thinking about these trends, from the North Gate runoff, and this is above any impoundments in the North Platte River Basin, from that region, we've seen an increasing earlier onset of snowmelt. And in fact, what we did is we just did a very simple mathematical test and said, okay, well, if it's warming about 2.21 degrees over this time period, even with the variability that we see in terms of precipitation, what does this mean for the timing of runoff? The timing of runoff, on average, is almost about 5 days for every 1 degree C increase in March, April, and May temperature. That's something that's measurable. That's something that we can identify and we can apply to resource models. When we're thinking about these changes, we need to think about them both today and moving forward. In terms of the past, we've experienced a fair amount of variability as it relates to long-term positions and shifts in the jet stream. In terms of the present, we can see a high degree of variability, largely related, again, to shifts in the jet stream. Moving forward, those shifts, that variability, is imprinted or superimposed upon by these increasing temperatures that we're seeing. Those increases in temperature sort of put us in a very interesting conundrum as we move forward from a water resource perspective. This figure is from a publication from Southwest Hydrology back in 2007. The left-hand column gives us a sense of historical droughts, the 1930s droughts and the 1950s droughts on that left-hand column. On the right-hand side, the authors essentially took a look at drought from a Palmer Drought Severity Index perspective and basically didn't change precipitation, right? Because if we're moving forward and we're thinking about changes in precipitation, it's either going to be wetter, it's going to be drier, or it's going to be the same. We can't get past that variability. But there is one thing that is changing in a unidirectional motion, and that is temperature. Temperatures are continuing to increase. So on the left-hand column, what the authors did is they actually looked at no significant changes in precipitation, but they added an increase in temperature of 1.4 degrees C. An increase in temperature of 1.4 degrees C increases the likelihood of drought occurring, largely because it plays a role in that early snowmelt, that early runoff. If we're not winter-dominated precipitation, if we're not summer-dominated precipitation in the interior Intermountain West, and we have an addition of increase in temperatures, that's a push on our water resources. On the lower right-hand side of this image, we're actually looking at no significant changes in precipitation, but a change in temperature of 2.8 degrees C. Moving forward. Now, what's interesting about this is that's something that they're predicting for the time period of 2035 moving onward. It's a very conservative look at increase in temperature because some portions of the western United States, some portions of the interior Intermountain West, even some portions of headwaters that we see like the North Platte have already seen about almost 2.5 degrees C increase in temperature, which is something that's projected for global-wide perspective. But when you look down in the watershed level, you can actually see places in the interior Intermountain West, our headwaters, that are already seeing those impacts that are projected for 30 years from today. But we see it right now. When we're looking forward into the future and thinking about even taking off the table the variability of precipitation, the notion of increasing in temperatures really impacts and really creates a push on those water resources. So the key concepts that I've tried to share with you today relate to notions of rates of change. We can think about changes in our climate on an orbital perspective on tens of thousands of years. Even on that sort of time scale, we still have evidence of long-term drought within the Intermountain West, which we'll very likely experience at some point moving forward in the future, regardless of our increases in temperature. That's something that's part of the variability of our system. However, if we include paleoenvironmental data, if we reconstruct past lake levels by way of looking at some of the geophysical profiles, the ground penetrating radars that I showed you, profiles that I showed you earlier, if we take that information in combination with changes that we see in vegetation, evidence that we see from charcoal in the sedimentary record, we actually can identify on a watershed level where there are variability and where there are extreme events. So we can tease out some of that variability and some of the extreme events that helps us understand what's going on. It identifies those extreme events, those changes. Using modern climate data gives us one more leg up in terms of understanding some of the processes that are involved, how the atmosphere is shaped, that persistence of high pressure. Obviously, that persistence of high pressure really impacted people in California with what they referred to as the ridiculous resilient ridge that deprived them of their wintertime precipitation for a number of years. Those are some of the same processes that affect our headwaters as well. So modern climate processes help inform us about past events as well. In addition to that, in terms of thinking about trends as we move forward, thinking about the increases in temperature, even without thinking about the variability of precipitation, we're still committed to an impact on our water resources as it relates to the early onset of snowmelt because of how quickly springtime temperatures are warming up within our region. So I hope I provided you with some perspectives of past environmental change, past drought, past fires, present day conditions and atmospheric processes, as well as thinking about what's going on and how things are going to be changing from a water resource perspective in the future, just to provide some broad perspectives. And with that, I have time for some questions, and I'm happy to hear from you all. Thank you again for your time.
Are there any questions for Professor Schenker? It was certainly a fascinating presentation. I enjoyed it a lot.
Thank you very
so
much.
much.
Thank you.
Thank you. Come back and see us again. Thanks. I'm now going to introduce the remainder of our panel. We're going to have two speakers who are long-standing members of the water community. I'm sure you recognize them both. On the right side of me as you face me is Mr. Cleve Simpson. He's the general manager of the Rio Grande Water Conservation District. He is a native of the San Luis Valley, went to college in Golden, and has been the general manager of the district for several years, succeeding Steve Vandiver and Ralph Curtis in that position. In addition to managing the district, he and his family operate an alfalfa operation south of Alamosa. On my left, as you face, is Rod Lenz. Rod is the president of the Republican River Water Conservation District. He has, for much of his life, operated a potato growing operation in far eastern Colorado, not too distant from the Nebraska line. And he has become deeply involved in the issue of how the Ogallala Aquifer is being managed and the efforts to figure out how to extend its productive life while at the same time complying with the Republican River Compact. They're both very thoughtful gentlemen, and the way we're going to proceed is Cleve will lead off with 15 or so minutes of explanation about the Rio Grande. He will be followed by Rod, who will do the same for the Republican, and then we will have a conversation about some of the matters that are the challenges in each of the basins that are similar between the basins and some of the ways in which those challenges are being met. So I would like to, at this point, ask Cleve if he would lead off with his presentation. And we're going to do it from the armchairs. Doug promised us that we could sit in armchairs if we agreed to speak. So we will. Cleve?
Very good. Thank you, David. Again, I appreciate the opportunity to be here and speak and deliver a message about the Rio Grande Basin. I would say I'm taking a bit of a lead from the AG this morning, and Phil Weiser and ties are absolutely optional and not required at Water Congress. I actually forgot to pack one, so. And then secondly, I appreciate Tetra Tech and keep a little stress ball handy. I'm sure it'll come in quite handy today. I'm going to take just a bit of a liberty as a speaker and offer up a bit of an opportunity to recognize Ralph Curtis. So I know there's a formal recognition of Ralph tomorrow. Ralph was the longtime general manager of the Rio Grande Water Conservation District, born and raised in the San Luis Valley. His contributions both to the Rio Grande Water Conservation District, the Basin, and Colorado Water Congress are just immeasurable. So Ralph passed away a little more than a month ago, December. Ralph's truly a mentor of mine. There's rarely a day goes by in the office that I don't come across something that Ralph touched or worked on. Those that know him would remember he was notorious for keeping a log, a record of irrigated ag in the valley on by hand with colored pencils. So there are colored pencils and charts scattered all across the office. So we miss you, Ralph. So the tagline for this conversation is addressing big water problems. David touched about kind of the process. Take a few minutes to offer some background, then have some discussion, some questions from David, We did not rehearse these in advance. David is the attorney for the Rio Grande Water Conservation District. I hope he keeps that in mind who signs his check when he tees up what I'm sure are real softball questions for. He's also the attorney for Rod, so I suspect Rod has the same expectations. The description for today also in 30 minutes was the intent to talk about, focus on Rio Grande water quality, quantity, challenges, opportunities, supplies, the future, a lengthy list to cover really in about 30 minutes. So I intend to try to go through some really 4 key points about the basin, and then I have just a handful of visual aids to help in that process. Yeah, and it actually works. So I would assume everybody understands or knows where the Rio Grande Basin is. The Rio Grande Water Conservation District comprises most of those valleys outlined within the basin, with the exception of Costilla County in the southeast part of the San Luis Valley. And the story, the message, really the 4 kind of key points I want to get forward today is the Rio Grande Basin is highly overappropriated. Surface water and groundwater. I've got a nice slide that depicts the surface water kind of representation of that over-appropriation, and really has been since the turn of the last century. And groundwater likely is highly over-appropriated. And then over the course of yesterday and today, there's nothing new to this group of folks, but persistent declining supplies or snowpack has had significant impact on our aquifer systems. So really over the last couple of decades, our demand is exceedingly outpacing the supply. Creates quite a stress on us. And then thirdly, unique to our basin maybe, is the interaction and the interconnectivity between the groundwater and the surface water systems. And really from an early on, a real lack of understanding of that relationship. And we're just now getting to the point where the science is actually catching up to the reality. So really what we're in the Rio Grande Basin faced with, I think, is really unscrambling this scrambled egg that we've taken decades to produce. The challenge for us kind of also centers around our whole culture. Our communities, our economies are really based on irrigated ag. And all of those cultures and economies and communities were put together on a water supply from the early part to the mid part of the last century that don't exist anymore. Pretty challenging for us. But on the positive side, I wanted to highlight we're actively working on solutions, really truly trying to balance supply and demand. And this is really coming, although mandates are pending, that we are actually forced into this mechanism. It was really out of self-preservation that the initial efforts came forth about trying to balance our supply with our demand. And really this will be the first year this year. Half of the groundwater irrigated acres underneath the Rio Grande Water Conservation District will be actively working to manage both the injury that those groundwater withdrawals cause to surface water systems and to work towards creating and sustaining our aquifer systems. So real tribute to the constituents of the San Luis Valley. And again, we have some pending groundwater rules and regulations. Water Judge Patty Swift is considering those and working towards drafting her order. But these producers have really stepped up in advance of that and actively working to mitigate the impacts of groundwater withdrawals. I touched just briefly about the mention about the Rio Grande being a microcosm of the Colorado River. So I kind of struggled with that a little bit initially, trying to think about that connection. I was fortunate enough this week, John Currier actually provided me with a paper he did in 2013 and presented to the Interim Water Resources Review Committee that outlined some of the similarities between the Rio Grande, and it was really kind of a message of let's not recreate or take the steps that occurred in the Rio Grande Basin. So again, I would highlight though that the Rio Grande actually should be and could be a model for how to move forward. But there was one really interesting piece of information in the paper that John worked on, and it was about gauging the change in water storage in Lake Mead and Lake Powell and comparing it to the change in our storage mechanism or facility, which is really our aquifer system. So John compared how those changed over time, and it's, I guess initially it was rather surprising, but when you think about it, it's not. There's an amazing correlation to the change in those reservoirs on the Colorado River system and the changes in our unconfined aquifer system. Of course, the magnitudes are hugely different. They're talking about millions and tens of millions of acre feet, and the Rio Grande Basin, we're talking about tens of thousands to hundreds of thousands of acre feet. And then lastly, the kind of connection or how the Rio Grande is potentially a microcosm of the Colorado River is the pressure for transbasin diversions and the continuing efforts to transfer water really from agricultural to municipal uses, generally on the Front Range. So the water plan talks specifically about the conceptual framework for discussing these kind of transactions, and we're really targeted and intended to talk about east slope or west slope to east slope transbasin diversions. This is really the potential for a conversation of diversions, for lack of a better term, from south slope to north slope. So that's a bit of the similarities. All right, and so I have just a handful of slides again to kind of visually represent what I've kind of highlighted. So this is a graph that Wilson Water Group put together as part of SWASI update, and it's really intended to just reflect. The blue graph is an accumulation of the decreed water rights on Water District number 20, which is really the Rio Grande River. And you can see by the end of 1892, 5,000 CFS of the Rio Grande River is appropriated. The two green lines represent 2005 is the lighter green line, which was slightly above average water year, and the darker green line is a 2010 flow of the Rio Grande over the course of a calendar year. And so really you're trying to make the connection there on 2005 during our irrigation season, which is presumptively 1st of April through the end of October. Every bit of the waters appropriated through 1880 are spoken for. The graph doesn't actually reflect. There are a small handful of diversions above the gauging station for the Rio Grande that the green lines represent, and it doesn't reflect return flows as well. Likewise, it also doesn't reflect curtailment for compact purposes. So in 2005 and 2010, that could have been as high as 25% of the flow at the gauging station at Del Norte is not available for diversion to assist with compact compliance. This is a chart everybody's seen, and it's a little deja vu all over again. It's a story that's been repeated for the last 15 months straight in the Rio Grande Basin, and today we're actually celebrating that we're now partially in only severe drought instead of exceptional or extreme drought. So trying to find a little bit of good in this discussion. And I apologize, this is from January the 24th, shows the snow water equivalent of the basin at 90-something%. I did see Brian Bledsoe this morning had one from today, which shows that at really 89%, moving the wrong way. I'll highlight, it was hard enough for me to get my presentation on Google Docs, whatever Google Docs is. It was impossible for me to update it this morning. I just gave up. And then this is, again, a graph most people have seen. The dark line represents current year. It's just a quick comparison. The green line is last year, 2018. The blue lines are record years. I'll put forward the concept. The Rio Grande Basin is not going to survive on average years going forward. We need some we need some of those 150% of normal years. And that's really, I'm not sure how well this graph is being displayed behind me, but this is kind of my most recent favorite graph to talk to. So this is the gauged flow of the Rio Grande at the Del Norte on an annual basis. So it's just a histogram from beginning in 1890. I have preliminary 2018 plugged in there at the very end. So a couple things come to light: the extreme variability of the flows in the Rio Grande. The blue line is the running historical average, so you can see the long-term trend continues to go down. The things I like to point out and highlight, though, is if you look at the last decade, so although we've had 3 years of slightly above average flows in the Rio Grande at Del Norte, we're about to approach a decade where the Rio Grande did not flow 700,000 acre feet. So there's not a decade in our history that we didn't have years above 700,000 acre feet. But even more surprising or important to me is to look at the last 20 years. So you'll notice in the last 20 years, the Rio Grande has never hit 800,000 acre feet. We had 1 year it got pretty close. But then again, if you look at every decade in our history, every decade, we've always had at least 1 year, and there's usually 2, 3, or 4 years where the Rio Grande flows more than 800,000 acre feet. So this is that, precipitous decline in the available moisture for our basin. So the direct result of that is how it impacts our aquifer systems. So just for reference, this is a map showing where the district has monitored and studied the change in the unconfined aquifer in the closed basin. It's a little hard to tell, but that shaded area is the area we've studied since 1976. It's north of the Rio Grande and generally west of Highway 17 from Alamosa to Moffett. This is a reflection of what that graph looks like. So again, we've been monitoring the change since January 1976. The red line is actually the running 5-year average. So you can see the aquifer was fairly stable from 76 till 2002. In 2002, the aquifer lost, for us in relative terms, we lost 400,000 acre feet of storage, pretty significant, which is really what drove us to these initial stages of self-preservation it's really the creation of sub-districts of the Rio Grande Water Conservation District for managing groundwater withdrawals. This first sub-district didn't come into operation until 2012. You can see how after 2002 we had a few good years, and then again another significant precipitous decline in the aquifer till what I'm hopeful is and confident in will be the lowest point in the aquifer, where in September of 2013 we had really reached a bottom point. So the first operating sub-districts whose goal and mission is to replace their injury to the Rio Grande River in this instance and recover the aquifer began operations in 2012, and we're really working towards recovering this, and you can see we were on really a pretty good path. We have under a decree and an approved groundwater management plan an objective to move that dashed red line up to at least minus 400,000 acre feet within 20 years. So we're making pretty good progress. Last year was a significant step backwards for us. Then next, really, again, I talked about it, what we're trying to do is come together as communities of interest. The basin is divided up into response areas, which really have become sub-districts of the Rio Grande Water Conservation District. Sub-District 1 has been operating for 7 years. Sub-District 2 and 3, which is in this depiction, the Caneas response area, will be operating this year. Sub-Districts 4, 5, and 6 of the district, which are San Luis Creek, Saguache, and Alamosa La Jera, are all formed, working on their plans of water management, and intend to be functioning and operational next year. I'm running out of time. The last slide is a screenshot I borrowed off of the web from a group called Renewable Water Resources that has come forward with a proposal for drilling wells in the confined aquifer system in the north end of the valley and piping up to 22,000 acre feet of water out of the valley into presumably to the Front Range to a municipality at some point in time. And it just again highlights the challenges that the district and communities are faced with. The district took a position 2 or 3 weeks ago in opposition to the proposal, and we have a long history of being engaged in these. They come about every 10 years to 20 years, every decade or so, and we'll take a very active role again in opposition to a water export proposal. So I'm going to turn it over to Rod and let him go through his slideshow. So,
Thank you.
oh yeah, you need that.
Thank you, Cleve. Before I get started, I want to just add one thing to the introduction that David gave me. Was I had the pleasure of serving 40 years for Lenz Family Farms, doing the potato operation and heading up that enterprise. And it got to the point where the next generation was ready to take it over. And there's such a need in the water business, especially in the Ogallala or everywhere in Colorado. I felt compelled to maybe make that jump to retire and to move more full-time into the position I have now. And it's not full-time, but it takes plenty. So today, I want to thank Colorado Water Congress for inviting the Republican River Basin to speak at your Congress, because this is, to my knowledge, this is the first time we've ever been invited to the stage, and it is an honor. It is truly a pleasure to be up here to tell you our story. And I'm going to start by, let's see, there we go, tell you where we are, who we are, and what we're doing. We are over top of the Ogallala Aquifer, as you well know. The 8 states that lie over the Ogallala all have a common problem. It's called the depletion of the Ogallala. And every state is trying to be innovative in how we deal with that depletion. And in the middle of that, the cross-hatched area, you can see the Republican River Basin that we're going to refer to today. Okay, there's a blow-up of the Republican River Basin in the 3 states, Colorado, Kansas, and Nebraska, that are engaged in the 3-state compact. You can see all the drainage bases, but this is the topic of discussion today. Next, this is our portion, Colorado's portion of the High Plains Republican Basin. And if you look at that colorful map, you'll see 7 different districts. Those are our groundwater management districts. And there are so many of them, and they are so diverse, it provides us some unique challenges, as we'll discuss in a minute. So take a mental note of this slide. I will refer to it a little bit later. So in order to tell our story, we kind of got to go back a ways and find out why some of the things, the conditions that are out there are out there. So let's go back to the 30s, the dirty 30s, when it was all dust. And that dirty 30 era was broken with a major flood in 1935. I'm told that there were between 22 and 24 inches of rain in a very, very short period of time over a very large portion of the southern part of the basin. And of course, this South Fork River that normally ran between 50 and 100 CFS at that time was all of a sudden 100,000 CFS. And it's got some personal marks as well, because our general manager, Deb Daniel, she tells me 3 of her ancestors perished in that flood. And because of that flood, some changes came to the basin. The federal government with the BOR and the Corps of Engineers decided to put in a series of flood dams. We have one flood dam that is called Bonnie Reservoir that's in the south end of our basin, and that flood reservoir was finished in 1950, I believe. And in the interim, it was our turn to enter the world of compacts. So in 1942, Colorado, Kansas, and Nebraska entered a compact as to how the Republican would be governed. So previous to this slide, from middle 1960s to 1982, we had a heyday of development of the underground aquifer. And we had some, oh gracious sakes, 4,000 wells, 500,000 acres went in, and just really a wonderful place to farm and to raise a family. And of course, you can't take a closed reservoir, closed basin and pump like crazy and not have effects eventually. And so after the beginning of a drought in 1998, Kansas says we're not getting our share of that compact waters, and they sued Nebraska. Well, Nebraska, of course, they says, well, Colorado's not giving our share, so they drug us into the suit as well. And so from 1998 to the time of a special master being appointed and to 2002, the three states negotiated and they came up with what they called an FSS, or Final Settlement Stipulation, in which all previous sins as far as shortfalls of delivery were forgiven, but going forward you would be held accountable. So with that comes the inception of the Republican River Water Conservation District. The state knew that they had to have some vehicle, some means to help deal with their requirements on the compact. So the state legislature formed in 2004 the RWCD. And the first thing they did was give us the ability to assess fees to assist the state in carrying out our obligations to the compact. And we started out with this fee of $5.50 an acre, and with the idea that if we could retire 30,000 acres, we thought that would probably, we were told, that would probably get us into compliance. And we got somewhere around 20,000 acres shortly, and the state quickly told us that this isn't going to work, we're going to have to do something different. And all heck broke out, honestly. Everybody was afraid of curtailments close to the river, far from the river. How was it going to come about? And it was really a time of just general chaos. So about that time, Dick Wolf was appointed the state engineer, and Dick brought a voice of calm to the room. And the first thing I remember, one of the first discussions I had with Dick, it would have been 2006 or so, maybe 7. He said, I need choices. I need some tools. I can't just have this awkward and somebody say, you're in compliance, you're out of compliance. I need some way to gauge that. I need a slide at the gate. And the idea of a compact compliance pipeline was hatched. He said on the north side of the basin, that would work if we could have a place to augment water into the stream to keep us in compliance, and we could call on when we need it. And on the South Fork, because of sub-basin non-impairment deal I don't want to get into, he said, if we take some drastic action on the Bonnie Reservoir to limit some of our accounting depletions, we may have a couple tools we can use. So those two objects came into play, and I'll talk about them a little bit more. But first of all, the Republican River, our job is kind of limited. We can assess fees, but we don't have any authority. We don't have any statutory authority for regulation. What our job is to help the state stay in compliance, and I will say we have done a spectacular job in the short time we've been in existence to get that done. But that really doesn't accomplish our long-term goal. Our long-term goal is to elongate the life of the aquifer. By encouraging water conservation is one way we do that, and full well knowing that our bottom line is really to keep the economic engines of our small towns going, perking along. Once again, it's a beautiful place to live, but everything is based on water and agriculture, really. So today, some of the efforts of the Republican River, since we can't use regulatory authority, we have a big bag of carrots. We can, by the way, our fee went from $5.50 to $14.50 in order to fund the compact compliance pipeline. And so we've got this bag of carrots, so we're out there trying to do the things we can without any regulatory authority. And the things we can do is to work in the alluviums. We've got 3 tributaries, the North Fork, the Arickaree, and the South Fork. And we're trying to acquire water rights. Sometimes we do it successfully, sometimes we get hung up in the legal system, and that's never fun, but we learn our lessons and go forward. But our idea is if we can procure the water rights in these 3 tributaries and get the water to flow to the gauge. It serves a couple purposes. It improves the habitat of the river for the environmentalists and the people who like the aesthetics. And for us in the compact compliance arena, it allows us to ding the gauge with water, is what we have to do with the downstream states. Now, I talked a little bit earlier about some of the conservation programs. We've relied heavily on EQIP and CREP, and CREP is a version of the CRP that eliminates water, of course, and these programs, highly leveraged, give us the ability to use the limited funds we have and to get a much greater reach. So this is one of those carrot things we can do and try to enhance the conservation aspect. Now I'm going to go back to the pipeline. If you look at the slide on the left, all the circles in purple are the circles or the fields ground that we acquired in a very large land purchase that had 13,500 acre-feet of consumptive use. It was some 10,000 acres, 58 wells, and that was a big deal. That gave us that gauge that Dick Wolf was talking about, and I can't say it enough. The only way this happened was through the help of the Colorado CWCB. They are just wonderful to work with. They've been just fantastic. I shout out to them. But we spent $48 million on the properties and the water and $12 million on a pipeline, and now the operational aspect of it. And it typically runs from October through the end of March, early April, and it depends on what our requirements are to keep us in compact compliance. And I can't tell you how hard this was to do. You know, you sit there and say, yay, yay, we're in compliance, or we have the method to be in compliance, but I can't tell you the number of people that come up to me and say, what the heck are you idiots doing? You're taking this pristine water, put it in the river, and sending it downstream to Nebraska and Kansas. And I says, you know, it hurts me probably as much as anybody because this is just below my place. And I tell them, I says, I agree it's stupid. So you and me, we're going to sit down around a table, we're going to sit around and we're going to stay there until we come up with a better answer. And I haven't had anybody take me up on it. So we're doing the best we can with the tools we have. And we know that this on the North Fork is just buying us time. It's not going to take us to sustainability at all. And then on the South Fork, that one is just as bitter a pill to swallow. It was the draining of Bonnie Reservoir. Now, in honesty, when 2011 came around and we drained Bonnie, it was going down anyhow because we did not have the inflows to keep it up. But we did drain it, and it was no longer a recreational lake, and everybody in that whole area used it all summer and winter, depending what your recreational preference was. And so to take that out, not only did it affect the people in southern Colorado and in the southern part of our basin, but the people in Kansas screamed about it probably louder than we did. But what it did, it took the evaporation penalty off of our accounting, and all of a sudden, we were in compliance north-south. And so for the first time, we seem to be in a position where we can control our own destiny to a degree. That's Bonnie drained right now. So I want to talk a little bit about, those are some of the conditions on the ground right now, and we have some, I won't call them crises. It's more like challenges. And some of the challenge we have is the mess that Bonnie left us. It's overgrown with 20-foot tall cottonwood trees, and they do nothing but suck up water, and a ton of cattails. So we have formed a coalition called South Fork River Restoration Coalition, and it's a cool group. It's unlikely stablemates, of which Republican River is one of them. We have two counties, Kit Carson and Yuma County. We have the Nature's Conservancy, Three Rivers Alliance. We have also Colorado Parks and Wildlife, and BOR is signed on as a supporter. We even have the Boy Scouts. So it's a really diverse group that is looking how can we handle to renovate or rejuvenate the Bonnie proper area, and in fact the whole South Fork. And we are in process right now of doing a stream management plan to look at the whole riparian area as to what works for everybody. The one thing we do agree on is that we need stream flow. And I'm convinced, maybe I'm optimistic, but I'm convinced that if we take care of the channel, the sediment, the excess trees, we will increase stream flow. Probably, in my hopeful regard, that we'll double it. And then we had a meeting this last Monday in Burlington. It was really kind of energizing because it went from a mess to kind of a wonderful mess, because all of a sudden we had a group of community members who said, what can we do with this to reinvent it? It's not going to be Bonnie Flatwater Entertainment. It's going to be something different. And person after person after person got up and said, I know somebody, or I used to live in the Front Range or in the mountains, and the traffic going to the mountains where people want to go, it is difficult at best. And he says, that provides us an opportunity for some kind of recreation out here, whether it be fly-ins, hiking, riding, trails. But anyhow, the energy was really contagious. And so I look at this as not so much as a disaster, oh, poor us, but maybe an opportunity to do something different in the future. Another challenge is that, I think it might be the next slide. There we go. When our district was formed, they formed our boundaries on the drainage, the surface drainage, and the actual domain or compact accounting boundary was different. So if you see the black line, and if you see the blue line, or the red line and the blue shaded areas, that's the difference. The blue areas, we're actually covering their compact depletions, and the people that are actually under our fee structure are in the tan. So about 3 years ago, we had some people inside said, so what's the deal with the guys out in the blue? Why aren't they also being assessed fees? And we says, I don't know. So we've dug into it, and the difference between the topographical drainage areas and the boundary domain, which is used in compact accounting. So we're in the process of right now of harmonizing the boundaries, and of course the people who are in blue don't want to be charged because they haven't been charged so far, and the people in the tan are saying, by golly, they got to be charged because we're paying their way. So we're working that out. We've got a bill going through the House and the Senate. House last week, it cleared, and the Senate will be next week. Hopefully we'll get that taken care of, and once again, we'll all be in the same bucket together. Another thing I guess I want to talk about is as we go forward, this whole bucket of this basket of carrots that we have, that slide I asked you to remember with those groundwater management districts, they've got the statutory authority to regulate, and it's difficult because they all have to fall under the Tabor issue, and so they've got authority, but they basically got no budget. So to defend, to promulgate any kind of rules or regulations, they've got a tough road ahead. And also, if you've got seven districts that are trying to put some kind of regulatory restrictions on diversions or well pumping, they almost have to act in harmony. Otherwise, one's saying, why am I doing this and nobody else is? So we've got that kind of infighting going on. And they've got a stick, we've got the carrots, but in reality, their restriction ability is more like a twig. They really can't force anybody to do anything. So that's kind of a problem that we have out there. Don't know. We'll just continue to work on the conservation aspect, and hopefully that will get us to where we want. And this next slide, as I close, is I don't know if that's a sunrise or a sunset, but I believe it should be a sunrise, because I think we've done so much in the last, 10 years of our existence, that I think if we can continue to maybe work with the landscape that's given to us, we're going to be in a place where we may get to the point where we can talk about that elusive word of sustainability. Now, sustainability on a closed aquifer, how does that happen? Well, we do have recharge. It's vertical recharge. We don't have any snowpack. We're the only basin that doesn't have any help from the mountains. So while Mr. Ryan said that we're somewhat immune to droughts, well, we also get our little bit of recharge from precipitation. So we can't ignore it. We got to look the long view. look at, or do we have water this year? Yes, we do, unless you're on the fringe of the basin that's running out anyhow of saturated thickness. But in the long view, we have got to get to the point where either we lead with conservation that is meaningful, or some kind of statutory regulation that we can actually squeeze, if we're going to talk about sustainability. Otherwise, we're pumping it to the bottom, and we'll deliver the alluvium water to the gauges as best we can. But that's good news, bad news. But I'm optimistic.
Thank you very much, Rod, and thank you, Cleve. I think what I'd like to do is sort of ask you both questions that probably are applicable to the two basins, and see if you can sort of compare and contrast your thoughts as it relates to your respective areas. First of all, it's clear from both of your presentations that you're dealing with declining amounts of groundwater available to your agriculturalists. What would your thoughts be about the need to reduce further the amount of use in irrigated agriculture in order to address these declining water supply conditions? Cleve?
The fact of the matter is it's inevitable for the Rio Grande Basin. So we have about 500,000 irrigated acres in the basin, and again, with dwindling water supplies, unless we're blessed with some miracle crop that consumes half the water, we're kind of restricted at the elevations we function at in the growing days. We're kind of limited on what kind of crop types are available to us. So I mean, we're really faced with the inevitable task of looking at some measurable amount of reduction of irrigated agricultural acres in the valley. So Sub-District 1 has been doing that through similar to what the Republican does with the CREP programs. They incentivize with their bag of carrots their own fallow program, EQIP, RCPP, any methods possible to, through conservation efforts, make some impact, but the eventual long-term sustainability of the basin means some amount of less irrigated agriculture.
Rod?
Well, for my part, to date, irrigators have always said, let's use technology and innovation to conserve. And that's all well and fine, but you can look at the numbers, and that's not going to get it done by itself. We'll continue to innovate, continue to use technology where we can, but in reality, the advanced, the good, the aggressive growers are the ones that are going to look for technology, and you've always got the, I'm going to call them bottom feeders. It's maybe unfair, it doesn't sound nice, but it's the truth, that if they've got water, they're going to pump it. And it's even worse yet than that. For some people have an appropriation, they're going to look for some way to maximize their appropriation just to keep their levels up, their historical consumptive use up. So we've got to pull some straws out of the tub. That's all there's to it. We all know that our communities depend on the water, and so while we talk about CREP being a great thing, if you're going to retire tons of acres and make them go dormant for 15 years, that is really it has a unintended consequence. Now, the new Farm Bill has a provision that at some point we'll hope is incorporated that allows them to go forward and to dryland farm and just take the water off and have a lower return rate. So that might be something we can use, but we do have to pull some straws out of the tub.
Thank you both. You're both involved in experiments within your respective basins by which the local community is actually attempting to solve the problems with water supply on a local basis. Are those efforts successful in your judgment, Cleve? And you might sort of, if you have not described those efforts, you might describe them a little bit.
Sure. So again, those efforts were really the sub-districts of the Rio Grande Water Conservation District, where those groundwater owners and irrigators have come together collectively in communities of interest to really assess themselves annual fees to raise revenue to advance programs that support their goals and missions, which again are pretty simple about replacing their injurious depletions and creating and maintaining sustainable aquifers. So with the, at least with the only one operational, Subdistrict 1, as highlighted a little earlier, we were making really positive strides, and I could say that I don't characterize what we're doing as an experiment, because an experiment implies that there's an opportunity to fail. I'm approach this in a much different mindset, that a failure isn't an option for us. So the producers are really coming together again to offer ideas, thoughts about managing this on their own, in their own ways. And Subdistrict 1, outside of 2018, was very successful in doing that. We've kind of had to take a step backwards and regroup. The other sub-districts that'll become operational are learning from those efforts of Subdistrict 1 what works and what potentially doesn't work and where the challenges are. The proof's still in the pudding, but again, failure is not an option for us. We have to fix this. We have to figure it out.
Ed?
For my part, I can say that 6 of our 7 groundwater management districts have flirted at least with some kind of self-initiated reduction program. It's gone anywhere from, on the south end of the basin, a thing called the LEMA, or Locally Enhanced Management Area. It's a Kansas program where they look at saturated thickness and appropriate a restricted level based on that. In the central part of our basin, it would be the WY district is looking at a kind of a Nebraska model where they just take so many acres per inch, you can bank it, and they're flirting with that. They are actually maybe even talking about a pilot next year. And there's 4 districts in the north, groundwater management districts, that are working with a thing called the water calculator. And what it does is it, in the simplest form, looks at your appropriations, takes a % of the appropriations. So if you're under appropriate, it's going to hurt you more than you're fully appropriated. But anyhow, you get a percentage of your appropriations, and that number, if you want more water because you've got a high use crop that year, you can actually purchase more water. And if you don't use it, you can bank it. That's the idea. But once again, we go back to that whole budget issue to implement these things. And I know in our 4 districts, we're going to try to look at the DeBruce factor, try to get us in a situation where we can have a little bit bigger stream flow of funding, so we can maybe implement something like the water calculator. And you're not going to just pass some legislature so you can have a bigger fee and the next year go right into some kind of cost restrictive program. It's going to take a while to build a war chest, if you will, so you can actually defend it. And it will be challenged, I guarantee you. It's just the rumor of it across the basin. There were people that were, are you kidding me? You can't do that. And I decided, I haven't decided, I just kind of gained knowledge, is that there is one conservation program throughout our basin that everybody likes, and it's pretty obvious, and it's the one that doesn't affect me.
Thank you. I think we all experience that. Conservation is very, very important, and my neighbor should practice it completely. You both are responsible for water resources management decisions in your respective basins. Both of the rivers that flow out of those basins have been the subject of U.S. Supreme Court litigation. Texas and New Mexico initiated their lawsuit against Colorado on the Rio Grande in 1966, and Kansas initiated its litigation against Nebraska and then Colorado in 1998. Do you feel that the water users within your respective basins understand and accept the responsibilities that the state of Colorado has to ensure that the downstream states into the future receive the water supplies to which they bargained for in the compacts?
Short answer is reluctantly yes, they've come to that appreciation. Somebody talked to me recently about, for lack of a better term, the paradigm shift in the late 60s and 70s where absolute administration of the river for compact purposes came into play. All those surface water diverters were probably at that time thinking about how are we gonna survive, how are we gonna manage under curtailment where we have a long history of not functioning that way, and then making that applicable to today's generation to go likewise. We've learned how to adapt, and I don't know that we've thrived, but we've survived under compact curtailment on the Rio Grande. Well, now the same kind of scenario unfolds for groundwater in the basin and it's challenging, but there's not an alternative for us, so we'll figure it out. So long answer to your question is yes, I think producers have recognized there's a need and a necessity for us to deliver compact as prescribed.
Rod?
Well, initially, our well users were blaming everybody. It's that doggone Kansas, it's that doggone Nebraska, it's that doggone RWCD. It's just a quasi-governmental organization, and we really had a terrible reputation. And there's a saying that I like to refer to when I get depressed, and it's like, it's hard to dislike someone whose story you know well. And so the state, I'm going to say Dick Wolf, go clear back to Dick Wolf. Dick Wolf was willing to come out at the drop of a hat if his schedule allowed it, clear out to the Eastern Plains on a regular basis. And so when you see Dick Wolf in front of you, if you've got the energy to go to the meeting, and over, and he's giving you answers from the top down, it's hard to dislike someone whose story you know well. And the Republican River, we've tried to take on that same attitude of if we're in the community. I tell people all the time, you got somebody in your neighborhood who's just screaming at you saying the state's stupid, Kansas stupid, the RWC's stupid, call me, just call me. And a lot of them do, and they're angry, and hopefully by the time I'm done with them, they at least understand the other side of the story. So we're relying on that saying to maybe change the dynamics of the conversation, and now they do get it, they do understand. It's not the big bad boogeyman, it's the law, the contract we signed. You may not like it, but that's what it is.
Thank you both. In both basins, you're working on community generated processes where you're using your own money, you're assessing yourself fees, either by irrigated acre or by acre foot pumped, to fund efforts to ensure compliance with the compact and to seek to manage the groundwater systems so that they are sustainable. After the number of years you've both been involved in this, do either of you have any thoughts that it might be better to change directions and go to a purely regulatory approach by which the use of groundwater in your respective basins is simply managed by the state to achieve the goals that you have set out versus doing it in the way you currently are?
Well, I can take that one before. I've got so many things going on in my head, I got to say it before I can't remember it. I think it's a bottoms up and top down both. In the reality, you like local control. You always like local control, I think, if you can do it. And sometimes you need some help from the top to be able to enforce it. But maybe even beyond that, another kind of generality is I like to look at the door that's partly open, the door that I can walk through. I don't want to look at a door that's got 4 locks on it and say, let's kick our way through it. So I look at the local control. What can we do now? It may not be the number one on my priority, but it's the most doable. Let's look at that. Now, if all the doors are locked from a local standpoint and you see the writing on the wall that some kind of conservation has to happen, then you've got to broaden your scope and say, all right, what's the next closest to local control we can accomplish? And at some level, like the formation of the Republican River Water Conservation District, it came from top down because that was the only way it was going to happen. So you start local, maybe go great.
Cleve?
Yeah, I concur. I think really the effort and the focus has to be local. It's probably the easier path is to shift that responsibility to the state and the division engineers. But the community was responsible for this condition we're in. I think the community can be the most effective way at solving it.
As you both know, my comment to the public gatherings that we attend together in both basins is that everybody spends a lot of time in rural America cursing the federal government, the state government, and other governments. And here, these two districts are providing their local water user community with the opportunity to take control, but going with that, take responsibility for the condition of their groundwater supplies. And so I'm hopeful that in both districts, everyone continues to say, we, as Cleve just said, we participated in creating the problem, and it's our responsibility to participate in solving it. And that's true in both basins. You can't, you really do, if you don't want the government to do it, then you have to gather together as a community, and you have to do it yourself. Those are my questions. Doug asked me to end a little bit early because he has some things he needs to do before the break. So Doug, you're on. Could you all join me in thanking Cleve and Rod?